Hello and welcome to this new tutorial on how to create a game like Solitaire. So you can see here the end result. Actually, I'm playing Solitaire on the game I created in Construct. It just works like any regular Solitaire. Let me see here. This is an ace, 6, 4. So as you can see, all the standard rules have been implemented, and it's up to you if you want to create this game to change the rules to something more exotic if you want to. So let's see how this works. Well, there's one main game layout here. You can see it here. The main game layout, it only has 3 layers. The background layer only has the green background. The placeholders layer contains the placeholders, which are the green facing cards. This one here and this one here and all the rest. And the hot zones here, these are the big purple areas. The cards layer here contains all of the cards. A card has to move to the card has a move behavior. Let's see up. So the card has a move to behavior in order to make it move to a certain pile. The pin behavior of the card is used to pin a part to a grabber, and a grabber is used to be able to drag multiple cards around at once. And finally, it has a drag behavior, of course, for it to be able to be dragged around. Cards also hold 4 instance variables. Suit takes care of the cards of the suit of the cards, H for hearts, C for clubs, S for spades, D for diamonds. The value is a number from 2 to 10, an A for ace, a G for jack, a J for jack, a Q for queen, and a K for king. A card is always on exactly one pile. Finally, there is a permutation number. Each card in the 52 deck card has a unique number between 0 and 51. The permutation table actually is used in the advanced random plugin. The table returns a number of 0 to 51, which is then a reference to this permutation number of the card. I'll show you in the code in a few minutes. As in every Solitaire game, there are 13 placeholders in the game, 7 piles near the middle of the screen, each starting with G for game, followed by a suffix of 1 to 7. At the top there are the BFC and the FFC labels. This one here, for example, BFC and FCC, which stand for back-facing cards and front-facing cards. At the top there are placeholders starting with the P, like this one, P for pile, which suffix H, C, S, and D, each for a suit. And all of the placeholders are referenced using the pile instance variable. You can see that in here. Placeholders are sprites with 5 animation frames. For the placeholders, frame 0 is used, but for the piles on top here, the other 4 frames, extra frames, can be used to identify the suit of one of the 4 top piles. The purple areas are the hot zones. They are used to detect where a card is being dragged to in order to highlight the pile. Each hot zone has a pile instance variable to identify it. You can see that here, pile G1 for example. The purple horizontal bar here is the divider. Its only purpose is to detect if a card is on top in the top zone or in the bottom zone of the screen in order to segregate the logic. Finally, there's a starting point at the bottom here. At the start of the layout, all of the cards are gathered here to be shuffled and distributed over the piles. Alright, so then there's a second objects layer here. The only object type of this layer is a grabber. You can see it here. The grabber has the pin behavior and is used whenever the user is dragging a card where other cards are laying on top of. So in that case, that specific card and all of the cards laying on top of it need to be taken along in the drag operation. Pinning a card to another card is a hassle in Construct 3 because of the way things work when they are picked and handled. That's why a grabber object is sitting in between. That may justify just a little more explanation on what exactly that is. So I'm going to start the game again to show you. Of course, not this layout, but this layout. So let's see. I'll have to make, for an example, I have implemented my right mouse button to restart with a situation that has more possibilities. Let's see if I can start over. What about this one? No. So you start over this way. Up. Okay, here we have it. For example, this one. Suppose you want to drag one of those cards. If you drag one card, you're just dragging one card around. But suppose you want to drag the 6 or the 7. If you want to drag the 6 or the 7, you take the 6 or the 7, and you want the 5 or the 6 and the 5 to come along with it. To do that, I've created a pin behavior, and in theory you need to pin the 5 and the 6 to the 7, or the 5 to the 6 and the 6 to the 7. But pinning two cards together in Construct 3 is a bit of a hassle. That's why I have the grabber behavior. I pin the grabber to the 7, and I pin the 6 and the 7 to the grabber. And that's how the grabber sits in between. You can't see it because it's invisible, but then you can see how that is being dragged around. Alright, let's look at the code. So the code is segregated into a number of sections. I'll just start with the base functionality to explain everything there is. So here's my little hack. We use the right mouse button to restart the layout. That's it. So the permutation table functionality of the advanced random plugin is used to randomize 52 cards in a deck. So we create a permutation table with 52 values starting at 0. That's just a range from 0 to 51. When you stop the animation of all cards, that's because every card has two animation frames. One of the front side and one of the back side. Sometimes cards are flipped around, and this is done using the set animation frame. And to make things more clear, two constants were defined, front facing and back facing, each with 0 and 1, which corresponds to the 0 and 1 animation frames inside a card, actually. So we initialize the moving card semaphore. Every time a card starts moving, this number is increased by 1. If the move to arrived event of every card, the number is decreased, and some logic can be executed when no cards are moving. Now next, we can call the shuffle and start function in order to start the game. We'll come back to that in a few minutes. And as part of the initialization, we need to set the placeholders to the correct animation frame by stopping the animation first, and then setting the placeholders frame to 0 to everything but the 4 top piles. And then for the 4 top piles, we pick animations frame 1 to 4 to set them to the correct back-facing animation frame. So shuffling is very easy. Use the advanced random plugin. Here you just shuffle the cards, and then we move all of the cards to the starting point at the bottom of the layout here. So when the distribution of the cards start, they all start from here and go upwards and not come from somewhere random place. And then we set the move speed to a bit of a higher level to make it move more quickly, of course. So this function uses the advanced random functionality, and after we looped it, after we did the permutation table, we're going to loop. So we're going to loop 7 times for each of the game piles, from left to right, 1 to 7. And in each iteration, a front-facing card followed by a back-facing card. So starting from the iteration in the outer loop. So we put a front-facing card and then 6 back-facing cards, and then we start at the next, the second pile. We put a front-facing card. We put 5 back-facing cards, and then we start at the next one front-facing card, and then 4 back-facing cards and stuff like that. So as we see here, what happens? Yep. So 1 front-facing, 1, 2, 3, 4, 5, 6 back-facing. 1 front-facing, 1, 2, 3, 4, 5 back-facing. 1 front-facing, 1, 2, 3, 4 back-facing. That's what's done here. So we have an iteration loop from 1 to 7, and then an inner loop which starts from this iteration loop to 7. So the first time it will start from 1, the second time it will start from 2, because then iteration will be 2, etc. So a loop within a loop, actually. So we pick the random card based on the permutation and the correct placeholder. So what we see here is that every single card, if you click a card, it has its own unique permutation number. This one is 4, this one is 16, this was 20, etc. So we shuffle the values from 0 to 51, and then we pick a random number, advanced random permutation for a counter. And the counter is this one here, and it's increased every loop. So we do it 52 times, or rather not 52 times, rather 7 and 6 and 5 and 4 and 3 and 2 and 1 time. And that's when it won't be 52, of course, because not all of the cards will be depleted, but it will already be a pretty high number. So we pick the card using the permutation number, and we pick the pile. And the pile is actually just a concatenation of the G and then a number denoted by the loop one. So we move the top, move it to the top of the layer so it doesn't pass below any other cards. And the cards we're putting in the iteration need to face forward, the others need to face backwards. So we see if the we set the animation loop to if the index of the loop equals the iteration loop. So if the index of the inner loop equals the outer loop, we set it front facing, otherwise we set it back facing. And we move it to its place. We set the semaphore and we call the move to behavior, and we use the constant card offset back facing to make a little more distinction between the cards in the Y direction. So let me show you here. Again, so the distance between this edge and this edge is the offset for the back-facing cards. That doesn't need to be a lot, you just need to see how many cards there are. But for example, if we put a card on top of one of another, you need to identify the value of this card. So this is the front-facing offset, which is a lot higher than the back-facing offset. So depending on what you see, we book the front-facing, sorry, wrong place. Here we change the Y coordinate to add some extra space for every loop we're in to have a bit of card of offset back-facing. We set the correct pile indicator of the cards. So every card needs to keep track on what pile it is right now to be able to track it down in the code. So that's what we do here. And once we've dropped all the cards, all of the back-facing cards need to be non-pickable. The user cannot drag them around. So that's what we do here. If the loop index of the outer loop is different from the iteration loop, it means it's back-facing, so the user can't drag and drop it. That's what happens. So now we've placed a number of cards, and the counter has reached a certain value. From that value to the 51st card, we place all of the other cards in the back-facing placeholder. So we pick the card with that permutation number, we pick the back-facing pile, and we put it on the back-facing pile. That's it, basically. The back-facing pile is this one here. So that's it. Interaction. let's see what it does. We use the drag and drop behavior. So what we do when the dragging starts, we need to keep track of the pile the card is coming from to be able to move it back if the users drag it somewhere it doesn't belong. So we set the starting pile variable, and we need to clear the drag dictionary. This is used when dragging multiple cards at once, and we move the card being dragged to that dictionary. That's it. So if we're dragging the top card of the pile, we checked it using the isTopCard function. We move the card to the top of the layer to make sure it passes above all of the other cards when it's being dragged around. When we're not dragging the top card, but the card further in the pile, in that case all cards on top of that card need to be dragged around. That's done using the object type called a dragger. The idea is that the card cannot be pinned to another card. This is inherent to the way the picking works in Construct. Therefore, a dragger is pinned to the card. All of the other cards on top are then pinned to the dragger by calling the drag cards along function. So first we clean up all the draggers that exist. There should actually be only one in a game at any given time. And we create a dragger at the X and Y coordinate of the card being dragged. That's it. We pick the last created one. And we pin it to the card, and then we call the drag cards along function, which I'll show you in a minute. The on drag drop, while a card is being dragged around, we detect if it is hovering over a hot zone. If so, the pile is highlighted by changing the scale. The reset highlight function will restore the scale back to normal for all piles when a card is dropped. So if the card is being dragged above the divider, all of the starting piles, or the starting pile is the front-facing card, that's what you do here, we search for the nearest placeholder that is one of the 4 top piles. So we pick nearest, and if it's one of those piles, we check if the card being dragged is compatible with the card on the top of the pile. We do that using the isPileCompatible function, which I'll explain in a minute. So if it's compatible, we move the card to there and we mark we mark it as found. If we haven't found anything yet, and if we're dragging below the divider or the starting pile for the front-facing cards here, we pick the nearest hot zone. We do this again using the pick nearest. And if we check if the card being dragged is compatible with the top card of the pile we're dragging to, again we're using the isPileCompatible, but instead of a top pile we use one of the game piles. That's it, and we mark it as found as one. And if it's still nothing found, we just move the card back to the starting pile. That's it. So while we're dragging, the only thing we're doing is first resetting the highlight, and if the card is below the divider, we pick the nearest game hot zone here, and we highlight that hot zone. That's it. So that's for drag drop, and drag is dragging. Here you can see the drag cards along function I used earlier. So I'll get a parameter called the UID of a card. So we first pick the card that's being dragged and remember the pile and the z-index of the pile. That's what we do. The z-index is the index of the bottom to the top of the layer on which how they are stacked one above the other. We pick the last created dragger we created earlier, and we pick all of the cards on the same pile but with the z-index bigger than the card being dragged around. That's what we're doing here. And for each of those cards we pin the dragger and add it to the drag dictionary so it's in the correct order. So for that we do for each card order by z-index. By doing the above step in the correct order, we can move the cards to the top of the layer in the correct order, so all of the drag cards pass above all of the other cards on the table. That's what we do here. We loop in the drag dictionary and we move all the cards to the top of the layer. That's it. So that now we're dragging all cards along. Cleanup dragger will just unpin every card from any dragger that exists, and then we destroy the dragger. So when a user clicks on a back-facing cards or on a card which is in the game pile, you can see here left clicking on a back facing card in the game pile and there is no card moving, then it means it is on the top card of a then we need to check normally if the pile is empty and there's only a back facing card. That card needs to get front facing. So that means, let me see here, let me try and explain this further using an example, because it's not easy to explain. For example, we put this 8 to this 9, then this is a back-facing card, but there is no card on top of it. There is no front-facing card on top of it. At that time, if you click it, it just turns around and becomes front-facing. And that's actually what we do here. So when I'm left-clicking on a back-facing card in the game pile and no card is moving, we for each of the cards we have clicked on here, we check off if that card is the top card. Yeah? If it's back facing and the top card, we set it to front facing and we enable the drag and drop function. That's actually what we do. When the user clicks the back of the pile of the back facing cards, so the pile at the top left here, the back facing cards, what needs to happen, we pick the top instance and we move it to the front facing cards by picking the placeholder first and moving the card there. So that's what we do here. When all of the cards in the back facing pile are gone and the user clicks the placeholder, all of the cards on the front facing pile need to be moved back in reversed order to start again. So whenever all cards from here have moved to there, this pile is empty, we need to move them all back again to start over, but in reverse order. So that's what we do here. If we click on the placeholders of the back facing card, we pick cards by evaluating every card which is on the back facing file, and only if we don't find anything, means that the placeholder is empty, we pick all the cards on the front facing pile, and then in reverse order of the Z index, so for each order by descending Z index, we make them back facing again, we disable the drag drop and we move them back to the placeholder we picked right there. That's it. So quite some logic here. Let me collapse. Then there's some highlighting. The highlighting of the hot zone. So in the highlight hot zone, we just get past two parameters, the hot zone and if we need to highlight it or not. We pick all the cards in the highlight pile and we set the scale depending on the highlight parameter. That's it. Reset highlights will just reset all of the highlights, all of the hot zones. That's it. All of the cards in every hot zone. Very simple. And then we have some movements, which we have some check functions, helper functions. First one is top card. You've already seen me use that. So it checks if this card here as a parameter is a top card. So we first retain the pile of the card being passed as a parameter into a variable, and then we pick the cards of that pile, and those cards, we pick those cards with the top instance, and if the UIDs are both the same, it means that it is the top instance, else it is not a top instance. That's a very simple function. Style compatible is somewhat more difficult. So this function checks if the combination of a suit and value passed as a parameter is compatible with the top card of the pile being passed as a parameter. So that's so if the back facing cards and front facing cards pile, this pile is never compatible. You can never drag it to the top left part of the game. If we're dragging towards one of the top piles, so the first letter of the pile, it starts with a P. We use the mid function for this. We get all of the cards on the pile, and of those cards we pick the top card and we check if the card is compatible with that card being dragged around using our cards compatible, which is a function I'll touch in a minute, which takes 4 parameters: a suit, a value, a suit, a value, and a pile. 5 parameters rather. So if nothing was found and the dragger suit is in the suit of the pile being dragged, and the value is an ace, then it is compatible. So that means if the drag suit is the pile here, is a P pile, and it's an ace, then it is compatible because it's the first card to be put here. So at that time there is no top card, so it wouldn't be considered as compatible. But for P drop zones, or for P placeholders, there is an exception. If there is an ace, then it is compatible. So that's what we do here. So if we're not dragging to a P pile, we're dragging to another pile, a G pile, because we're also not dragging to these two. So we pick the top instance again, and we set compatible using the rcards compatible function. And if still nothing is dragged, but the dragged value is a K, it means that it's still compatible if a king is being dragged to an empty space. That's yet another exception, of course, in solitaire. So that's already pretty complicated. And then we still have a last helper function, cards compatible. So the function takes the dragged suit and the value combination, and the reference suit and the value combination on a certain pile. So first we check if we're checking the compatibility of a game pile, else we're checking the compatibility of a P pile. So in the G compatibility check, we check first the suit. If the suit is not compatible, it's already not compatible. So the return value here starts with considering 0, means that by default we start from the assumption that it's not compatible. So we only set a 1 to the result value whenever we found something that is compatible. So everything else we exclude. So if it's not the dragged suit, if it's the same suit, then it's not compatible. So a heart can be on a club, but a heart cannot be on a heart, for example. So what we do here, if it's the same thing, the same suit, it's already not compatible, and then we check the suits if they are compatible with one another or not. Once we know that the suit is okay, we check on further. And then we see if the drag value is an A and the compare value is a 2, then it's okay. If it's a 2 and a 3, then it's okay, etc, etc, etc. That's how we set the return value. And then when checking the P pile, of course, it needs to be exactly the same, so the vice versa of the last condition there. And then we check in other order. So A means it has to be on top of nothing. 2 needs to be on top of an A. 3 needs to be on top of a 2, etc, etc, etc. And finally, we return return value. That's it. So, and then last but not least, we have the card movement. So here we have we move a card to a certain pile. So first we pick the card that was passed along and retain the Z index in the pile. So if we're moving to a game pile, we check it here, the piles are equal, we're moving back to the same pile. So the reference pile and the pile, reference pile being the pile of the card being dragged around, and this pile are the same, means that we're just moving it back to its original place. We pick the topmost card of the same pile with a smaller Z index here. We pick the top instance, we set it to found, and we set it back facing. We set the facing, sorry, to the animation frame. So that's what we do. Else, we're not dragging to the same pile. We're dragging to another pile. We pick the top instance and retain its coordinates. So if something is found, if nothing was found, rather, we pick the placeholder and retain the placeholder's coordinates. And so we've done nothing but gather coordinates, x and y coordinates, and move the card towards those coordinates. So we move the correct we move to the correct coordinate. The x is okay, but y depends on the pile that we're facing and the card we're moving to. When putting the card on top of a back-facing card, the offset needs to be that high. To the back-facing card, the offset doesn't need to be that high. When putting it to a front-facing card, there needs to be more offset to be able to read the card. That's what I showed you earlier. Top piles don't need any offset, and that's the expression, somewhat more complicated expression you can see here. So for top piles we don't need new offset. For front-facing cards there is a larger offset, and for a back-facing cards there's a tiny offset in the Y direction. And then for each key, in the drag dictionary we pick every card with that key and we set the pile to the current pile. Else we drag into the top pile our front-facing card, then we pick the correct placeholders by its X and Y coordinate. We pick the card and move it there. That's it. That's all we do. So when we're dragging to a P or an FFC, which is here or there. So on move to arrived, the only thing we do is we subtract 1 from the semaphore, and if no cards are moving anymore, it means that we can enable the drag drop functionality if the current pile is the FFC pile. That's it. So that's a pretty lengthy tutorial with some logic. If you're confused, you can always watch it again, and you can get the full template in the Syrah store, for which I will leave a link to in the description below in the video. As always, please like and subscribe, and thank you for watching.